Good morning, good afternoon, or good evening, depending upon where you live around the world. While I was fiddling with my ideas for the hub, something in the back of my mind from earlier on, from something I'd been doing, kept on nudging me to look further. In my attempt to create the hubs, I based this model off of my what I think, well, it is accurate, honeycomb model, so that I could, as we can see here, the red with these whitish surfaces are what I replicated down below just previously, so they're in exactly the right position on the strut, the orientation relative to each other, and any other angle that would be required, the height difference, as I keep on referring to the relative height difference of the struts to each other. So everything was and is as it should be. I was happy with that. I knew I had these angles for the two struts, the angle between the two struts in the plane of the surface, as if we had a solid surface. I was happy with that. Then I created that hub example, which I've drawn back here. So this would be the top of the hub, and down below here would be the bottom of the hub, of the dome, sorry. I started rotating items, and I was getting this little discrepancy that I couldn't track down. Still don't know whether it's the correct or the issue is what was causing that, but I went a little bit further. Now, if you recall, the measurement up top on the honeycomb was 87.3. And remembering that these are the 6 plates, I'd shown 3, but I reflected them over to this side as well, but the 6 plates of that hub. I proceeded to draw lines to the centre lines of those tabs. I then put my protractor on it. I go from one line to the other, and if you look in the bottom right hand corner, it's 89.3 degrees, not 87.9. So we've got 89.3 there, but we've got 87.3. Where do those other 2 degrees go? I was wondering whether the difference actually came about because this is being generated, these angles are generated on a flat horizontal surface. I did not think there would be any difference from the way I had it shown in the hub. I'm going to enlighten you now to clarify my stumbling wording. But I ran the centre line up on the actual surface. This line, actually I'll just try and get rid of that. This wee centre line here, well, it is a centre, and this one here would have been the equivalent on the dome. This would be the surface I was mentioning. So I take my protractor, I'm on the surface, so it's inclined somewhat, and I go between those lines. We've got 87.3, exactly the same as we've got on the model. So that small difference between measuring and rotating items from a horizontal position to an angled position gave a different angular reading. I had wondered about that, but I had concluded from what I'd done thus far that no, it wasn't going to be a problem. I think I'm wrong. Well, I know I'm wrong. It's only a small amount to worry about, a 1 degree each way, but part of this exploration was I'm trying to create, just as an exploratory effort, another way of creating an adjustable hub. What I'd seen many times, very good quality domes have got a little, very slight misalignment. In itself, it's not really of any structural issue, nor really any impact aesthetically. But time and time again, I'd see these photos with this aberrant alignment of the plates and the struts. My way of thinking is there shouldn't be any, but I kept on seeing it, and I wondered whether there may have been an issue with the way the items were made in the physical realm compared to the geometry as in a drawing. Possibly not. It may have just been the inability of the items to align in the real world. Just the inbuilt tolerances. But that really puzzled me. It really has. So that was why I thought, if I can make the tabs and the struts, these tabs and the struts, perfectly aligned, and then assemble them onto a hub structure, would that look better? And how would I do it? And while I was doing that exercise, it reiterated the difference in heights, because you can see here this strut relative to this strut is at a different height. And therefore, if we're trying to make these tabs land on a flat plate, it becomes problematic. It would necessitate us deciding to have maybe a couple of millimeters lift here and a couple of millimeters of drop here, just to average it out, what we call 60-40ing it. 50-50 means you're getting it about right. 60-40 means you're getting it's a bit of a fudge to get something to work. Building site terminology. So, what do we do? Well, that's going to be the next question, because the necessity for, in the pictures I've seen, I'm wondering that when the people lifted or lowered struts to make them land on a flat plate, that they introduced some sort of geometric inaccuracies or misalignments. Because I'm sure whoever's gone to the effort of creating the hubs and cutting the struts, they would have done a sufficiently good job, but did they take into account any possible changes when they flushed up the timbers? Because we know from this example we got a 2 degree, a 1 degree each direction misalignment. I've got a feeling that may have contributed to the issue. Again, not a problem per se, but when you're looking at a photo trying to nut out the what you're seeing and why you're seeing these little anomalies, it's good to at least go down an avenue of consideration, so that if we take care of that earlier on, we may not get caught by it. Now, what I'm aiming to do is to have my tabs, they can be bent to specific angles to accommodate my differences in the struts, but they land on a plate so that they'll come up and then they'll angle, instead of being still inclined, they angle to the plate and drill through the plate. Well, the plate will be drilled, there'll be a hole in the tabs, and they can bolt together. I have, however, seen this where there seems to be a slewing effect between the hubs, the tabs, and the central hub or plate, which looks like it's a misalignment. So, can we put two bolt holes in, one which pivots and assembles the dome initially, and a second hole that makes it rigid? It also distributes the forces, the shear forces, through two bolts rather than one. Again, doesn't have to be, they don't have to be big and bulky, but they do need to resist those shear energies. I'm still convinced that having a plate top and bottom would be advantageous, and that they can be fixed with screws, much to my not surprise that I've gone down that route, but I think for construction purposes they would be better than having through bolts, which is my preference. So I suppose I need now to finish off this. I've made this before I'd finished my little project. So I suppose I need now to carry on and finish it with this added bit of information now under my belt. And possibly now, if you go to do a model yourself, you can use this information to at least, again, as I've said many times, be aware of the issue. A tiny issue that could trap you. I'll leave it there. We'll come back with the next video with these tabs finished and in place, but they'll also, I'm saving them in iterations from one to another, so I can back step to see where I've come from, and the next one will have the tabs lifted or lowered to a specific height, and we'll know what the tolerances are, or roughly. Okay, that's it. I'm off. I'll see you again in the next video. Okay, bye.